Hey, in this lesson I'm going to go over complex numbers, what they mean, and how we can use them with the normal mathematical operations that we are used to. So first, what is a complex number? It is represented as I. What does it mean? It has a value of the square root of -1. So this might be new because you're probably used to not being able to take a square root of a negative number, but now this changes. So for example, if I ask you, what is the square root of -4? You can rewrite this as the square root of 4 times the square root of -1. Pretty simple. Square root of 4 is pretty simple, which is 2. And now we know that the square root of -1 is equal to I. So the answer is 2I. Once again, it might seem a bit different, but you can think of it as a variable that represents a number. So I is a variable like x, like you've seen before in algebra, and its value is the square root of -1. So now let's move on to a few examples of actually using this using mathematical operations. Okay, so the first example here is 2 plus I minus 2 plus I. So very simple, but our first step, like once again, think of an algebra question. Our first step is to combine like terms. So the like terms, or the whole numbers, are 2 and -2. Those go away. 2 minus 2 is 0. So we have 0, and then I plus I is 2I. So 0 plus 2I is the exact same as just 2I. So very simple. Once again, think of it like an x you have seen in algebra before. Very, very simple. Our second question is 4 minus 3i plus 2i minus 5. Once again, combining like terms, we have 4 minus 5, which is equal to -1. And then -3i plus 2i is minus I. So our answer is -1 minus I. Pretty simple. Question number 3, once again, very, very simple. We can expand this negative onto each term in the brackets, like once again we are used to in algebra. So this will be the exact same as 2 plus I, I'm just rewriting the first bracket, and then minus 3, and then minus 2I. Very, very simple. Now we can combine like terms once again. So we have 2 minus 3, which is equal to -1, and then I minus 2I, which is equal to -I again. So we have the exact same answer like the previous question, but that's just coincidence. Question number 4. Let's once again expand the -2 onto every term in the bracket. So we have -4 plus I, that's the first parenthesis here. And then for the second piece of information, we can rewrite this as minus 10, because -2 times 5 is -10. And then -2 times -5i is positive 10i. Very, very simple. And now if we combine the like terms once again, we have -4 minus 10, which is equal to -14. And then positive I plus 10i is equal to plus another 11i. And once again, just like that, we are done. And that is how you add and subtract complex numbers. Now let's move on to multiplication of complex numbers. Okay, for the second part of this lesson, we're going to multiply complex numbers. This should be very similar to addition and subtraction, but with a little bit of difficulty that we might not expect to see with these type of problems. But let's just do it anyways. So first, like with any other multiplication of a binomial, we can just expand both brackets. So we have 3 times 2, which is 6. 3 times -I, which is -3i. I times 2 is positive 2i. And then I times -I is -I squared. Okay, let's pause here for a second. We do know that I'm going to write it on top here. I is equal to the square root of -1. If you square I squared, this will be square root of -1 all squared, which is equal to -1, right? So in theory, this I squared is equal to -1. So let's substitute that. We have 6 minus 3i plus 2i, and then minus -1. This minus is this over here, and then the I squared is the -1. Okay, now, once again, if we combine like terms, we have 6 over here, 6 plus 1, which is 7, and then -3i plus 2i is minus I. So that is the answer here. And once again, if you have any squared or any exponent on an I, you can always change that into -1s, or I guess multiples of -1s, but that should be pretty simple. Let's do the exact same thing with this question here. So first we can do 7 times -2i, which is just -14i, and then -I times -2i is positive 2i squared. This will be very simple once again, because I squared is equal to -1. So I'm going to rewrite this as -14i plus 2 times -1. Now this is once again very simple. We have no like terms in this question, so the answer is just negative 2 minus 14i. So once again, I'm just treating these numbers as algebra variables that you've definitely seen before. Okay, let's move on to question number 7. Let's do the exact same thing, but first we have a coefficient here, so let's multiply that by the first bracket. We're going to get 8 plus 2i. That's the first bracket if you expand the 2, and then that is multiplied by 2 plus 7i. So I'm going to rewrite that. Okay, our first step, once again, expand each term. So 8 times 2 is 16. 8 times 7i is 56i. 2i times 2 is plus 4i. And then 2i times 7i is positive 14i squared. Once again, let's substitute that I squared to become a negative 1. This is equal to 16 plus 56i plus 4i, and then plus 14 times negative 1. Let's combine the like terms. This is equal to, if you combine 16 and negative 14, that is 2. And then 56i plus 4i is positive 60i. And that's it. We're done with this question. Okay, for our last question here we have 3 parentheses being multiplied together at the same time. Once again, we're going to treat it like algebra, nothing special and nothing new. So first, let's multiply the first 2 parentheses. 6 times 7, I'm going to write it here, is 42. And 6 times 2i is positive 12i. Negative I times 7 is minus 7i. And then negative I times 2i is negative 2i squared. And then all of this is going to be multiplied by negative 4 plus 3i, because that's our third bracket that we have not touched yet. Our next step is to probably substitute the I squared, because if you start multiplying right away, you're going to get a lot of unnecessary terms that you could have avoided if you simplify first. Okay, so our rule is to simplify first always. So I'm going to plug in negative 1 into I squared. We have 42 plus 12i minus 7i minus 2 times negative 1, all multiplied by negative 4 plus 3i. Now let's combine the like terms. 42 plus 2 is going to be 44. 12i minus 7i is positive 5i. So that's the first kind of bracket. And then all this is being multiplied by negative 4 plus 3i. Now, very simple. You can think of this now as a whole new question with just 2 binomials, which we've seen in previous examples. So now we can do 44 times negative 4. So 40 times 4 is 160. 4 times 4 is 16. Add them up together, you get negative 176. That's just a bit of mental math. You can do it on the side if you need to. And then 44 times 3, so 120 plus 12, that is 132. So positive 132i. 5i minus 4 is negative 20i. And then 5i times 3i is positive 15i squared. Once again, let's substitute our negative 1 into I squared. We have negative 176 plus 132i minus 20i plus 15 times negative 1. Let's start combining like terms. We have negative 176 minus 15. That's going to be negative 191. 132i minus 20i is just positive 112i. And that is our final answer. If you notice, with every single question we've done, our final answer is always a term of a whole number and then a term of an I. Same here, a term of a whole number and then a term of an I. And then same with the 2 questions here, a whole number I, a whole number I. This is going to be the case for every single complex number multiplication question, because you always have 2 sets of different numbers, and you cannot have a third set, because if you have an exponent on the I, you can always change that into a whole number, because that will be something times negative 1. Okay, but I hope you enjoyed it. I hope you understood. If you have any questions, leave them in the comments, and hopefully I'll see you again in the next video. So yeah, that's it.